In this lesson, I'll talk about the cloud. What is the cloud? And by the end of it, you'll really be able to tell me what the cloud is and tell other people what the cloud is and really discuss the key components of the cloud and what makes the cloud so important to us today. Let's define what cloud computing is first. So going back to NIST, the special publication 800-145, they define the cloud really as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, e.g. networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. The cloud model promotes availability and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. So we're going to talk about a couple of those today. So how I define the cloud? Well, really the cloud to me, and you guys can use this definition too, and the way I explain it to somebody that says, what is the cloud? Really, it's just somebody else's computer. That's all it really is. It's somebody else's computer on somebody else's network with someone else's policies in place to manage it. So think about the power usage, think about the incident response, think about nearly everything that you do with a computer at your organization, think about it somewhere else. So Microsoft Word, for example, take that's installed on your computer and put it out on somebody else's computer and access it from your computer. That's what we actually call Office 365, is Microsoft has that in place. So there's a few different models that we have. NIST, the special publication 800-145, really defines those 3 service types as really services, the computing model. So software as a service. Software as a service is really software. So think about the software that you have on your computer. Microsoft Word, Microsoft Excel. Those could be put out in the cloud, and they actually are through Office 365. This is probably one you're more familiar with. Platform as a service. A platform as a service is, well, think about your operating system that you're on right now. Whether that's a mobile platform, whether that's a Windows platform or an Apple platform, you really can't virtualize Apple. However, the platform as a service, think about the operating system. So if you have an operating system and you put it out in the cloud, what can you do with that? You can install applications on it. You can manage resources. That is a platform. And then finally, we have infrastructure as a service. Infrastructure as a service is really your computer. It's hardware. So think of servers, for example. So think about infrastructure as a service as our final service that we have. So servers, for example, we could manage infrastructure like number of CPUs, number of how much RAM we have in it, what kind of network it has with it. That is infrastructure as a service. It allows us to put anything and everything on that model as a service that we want to, but it's hosted somewhere else. Other types of networking that we could use as a service are things like networking as a service or data as a service. Anything that we can basically virtualize and have somebody else run it is part of the overall cloud model. However, software, platform, and infrastructure are really what we consider the 3 models that the cloud uses. Let's talk about the components of the cloud. components of the cloud are really rapid deployment. So there are companies out there that provide many different services. They provide all the software, platform, and infrastructure services, but we're able to deploy them instantly. Think about when you're setting up your computer and how long it could take, or think about setting up your phone or a server, for example, if you're a system administrator. The cloud allows us to rapidly deploy anything. That could be software, platform as an operating system, or it could be infrastructure as well. The cloud allows us to do flexible architecture. So if it's software, maybe the software provider, and we'll talk about the SaaS model here in another lesson, but the flexible architecture in software could be the amount of concurrent licenses you're using. It could be how the system is running as a whole. We also have resource pooling. So resource pooling, we usually see this across multiple systems. So if we have a huge server farm, we could stick all the compute cycles together or the cores together and really allow us to pool those resources so that we only realize one system versus a multitude of systems. And then finally, the other component of the cloud is resource measuring. In order to be an effective cloud provider, you need to have some way of measuring how much that you're using. And this is passed on to the end customer. So whether that's, again, concurrent licenses for your software as a service, or maybe it's a number of compute cycles on a platform, or even CPUs, for example, on infrastructure, there's all kinds of resource measuring that we have that cloud providers allow us to access. And that's how the cloud is usually structured. NIST Special Publication 500-292 really goes into the overall reference architecture of the entire cloud itself. So in this, we have the three types of platforms or as a service that we have, so software, platform, and infrastructure. And then we also have other components such as cloud brokerage and some other components that make up the cloud. So why is the cloud so important? The cloud allows us to rapidly deploy where we may not be able to rapidly deploy on site. It allows diversification of architecture and location. So maybe you don't have an office halfway around the world or halfway around the country. The cloud allows us to diversify where we put backup systems or compute nodes that allow real disaster recovery to happen. Think about security as well. Cloud architecture allows us to let somebody else manage overall workloads and monitor what's going on with our services, so that if we don't have the personnel to do it ourselves, then we can allow somebody else to do it. We also can see sometimes a decreased workload when we move to the cloud. Now that's not always the case, and you need to be real careful about workload when you move to the cloud and say, well, really everything is going to the cloud. So let me give you a scenario for this. Let's say that you have a directive to move everything to the cloud. Well, let's say that is servers, for example. Now, a lot of cloud providers will charge you to move data up. To pull data down. So if I move data up, let's say I move 20 gigabytes worth of data up to the cloud, and that keeps on growing and growing and growing. And then 2 years later, what happens if that cloud provider goes away? Well, now I have to download all that data and then select a new provider to host that out in the cloud, where that may take several months to do that on a poor connection. Or what if the cloud provider all of a sudden goes out of business? It's going to create more work for you to move that cloud provider somewhere else. So it's not always an advantage for organizations to move to the cloud. Disaster recovery is another one of those important features of the cloud. So we can host other servers all across the world. If we load balance servers across the world or across the country, then if we have a disaster in one location, we can diversify and go to another location that's backed up, for example. The cloud gives us a whole variety of options that normal on-premise solutions don't provide us.